Problem number 43, we're going to solve a system where here our coefficients are complex numbers instead of real numbers or whatever you're used to solving systems for. So there's a lot going on in how this is presented in the textbook. We're going to first start by translating this to how we normally write down systems. So let's rewrite. And what we have here is two equations. We have first the equation iz1 minus iz2 is 3 minus 5i. Let's write that down. And then we have another equation, which is here in the middle. So that is, the middle term is equal to the right term. So we have 2 plus 10i minus z1 plus 1 minus I z2 is 3 minus 5. So that's our system. We want to solve it for z1 and z2. So the way in which we solve systems of equations over the complex numbers is the same as the way in which we solve them over the real numbers, or any field for that matter. We use Gaussian elimination or substitution or whatever method you like. It works just as well over the complex numbers. So I'm going to start by moving all the constants, namely this guy here, to the other side. So we'll leave the first equation alone. And I'm going to subtract over 2. So 3 minus 2 is 1. In fact, let's write the negative 2 under both of these. And we're also going to subtract over 10i. 5i, negative 5i minus 10i is negative 15i. And then what's left on the left is negative z1 plus 1 minus I z2. Great. Now we have a system sort of like we normally have it. We have something times z1 and then something else times z2 is equal to a number for our first equation, and then a similar thing for our second equation. I'm going to use elimination because that's the way that I prefer to solve things, because it's sort of an algorithm that always works. So what we're going to do is we're going to multiply this second equation by an I. And we're going to multiply that second equation by an I so that when we add our equations, if there's a negative iz1 on this bottom guy, they'll cancel. So above in blue, I'm going to put the result of multiplying by I, namely what the coefficient is. So we multiply negative 1 by I, we get negative I. Let's do some scratch work over here on the side. If we multiply I times 1 minus I, we get I minus I squared. But I squared is negative 1, so that's going to be a 1 plus I. So that's going to change to 1 plus I. And then we're going to multiply this last guy by an I. Let's do some scratch work again on the side here. So that's going to be I minus 15I squared. But I squared is negative 1, so we get 15 plus I. All right. Now we're going to add equation 1 to equation 2. Well, I times equation 2. And that's going to be the new equation 2. Okay, so we're going to leave our first equation alone. And I'm going to add the coefficients of the first to our blue coefficients above our second equation. So this first one's going to be a 0 because we have iz1 minus iz1, that's 0. And then we're going to have negative iz2 plus 1 plus iz2. So the i's are going to cancel and we're just going to get a z2. And then our last guy here is going to be 3 plus 15 is 18. And negative 5i plus I is negative 4. Let's scroll down a bit now. So now what we have is actually we have a number for z2. Z2 is that. So what we're going to do now is just plug in z2 into equation 1. We have iz1 minus I. Now our z2 is 18 minus 4i, and that should be 3 minus 5i. And so let's multiply negative I in. So we get negative 18i. Negative I times negative 4i is 4i squared, positive. And let's see, we can rewrite our I squared as a negative 1. So we have IZ1, and then minus 18i minus 4i is 3 minus 5i. And then we're going to go ahead and, oops, there should be no I there, sorry. We're going to go ahead and add 18i, let me just use red here. We're going to go ahead and add 18i and 4 to both sides. And when we do that, we get negative IZ1 is equal to 3 plus 4 is 7. Negative 5 plus 18 is 13. So 7 plus 13i. And then we need to go ahead and divide by I. So take both sides here and divide by I. And when we do that, on the left-hand side, we get a Z1. They cancel. And on the right-hand side, we have 7 plus 13i over negative I. Now a trick when you're inverting I is I times negative I is negative I squared is 1. So what this tells us is that negative I inverse is equal to I. Namely, when I multiply negative I by I get 1. So it must be that I is the reciprocal of negative I. So really here, we could go ahead and rationalize and do all that stuff. And you get the same answer. But really, dividing by negative I, is the same as multiplying by I. And so we get 7i plus 13i squared. I squared is negative 1. So that gives us a negative 13 plus 7i if I write the real part first. So here is Z1. And so in particular, we found a unique solution where Z1, Z2, well, we just found Z1 is negative 13 plus 7i. I've forgotten what Z2 is. Let me scroll up for a second. It's 18 minus 4i. And there we have it. So the point of this example is that, the usual linear algebra computations we know work over the complex numbers. The only difference is multiplying is a little bit more involved and division is a little bit more involved, but the algorithm still works.